In order to simplify 440, the square root of 448, what I do is I need to find a good starting point. So I took half of 448, which was 224, but I'm not doing anything else with that 224. It's merely serving as a spot, as a number to tell me where's a good starting point in my list of square numbers. So as you can see, here is my list of square numbers starting here, working my way down, and then going back up to the list continues over here. I didn't have enough room to continue writing my list, so I just continued it up here. I hope that's okay. So anyway, I want to know which of these numbers is a square factor of 448. And so what I'm going to do is going to take my calculator and I'm going to start dividing. So 448 divided by, so I would start with 196 because that's the first number that's close to the 224 that I got. So 448 divided by 196 gives me a decimal. So that's not the answer. So I'm going to go 448 divided by 169. I get a decimal. I'm going to keep going. I'm going to try 144. It's not going to work. 169 won't work. 144 isn't going to work. And so to save some time, I know that the first number that's going to work going up my list is 64 because I want the biggest square factor. If you start with 4, well, yeah, 4 works, but my gosh, it's going to take you so many steps to keep simplifying that I just don't want to do that. So I'm going to rewrite this as the square root of 64. And when you divide 448 by 64, it goes in 7 times. The square root of 64 is 8. 7 does not break down anymore, so 8 square roots of 7 is the answer. Let's look at number 2. So the rule for these is always that you want to multiply those together. So that's going to give me 2 square roots of 12. 12 breaks down into the square root of 4 times the square root of 3. The square root of 4 is 2, so I brought this 2 down, but the square root of 4 is 2 times the square root of 3, and 2 times 2 is 4 square roots of 3. So that's that answer. I come over here. The problem with number 3 is that we're not allowed to have a radical in the denominator, so I have to rationalize my denominator by multiplying the denominator by the same radical, and whatever I do on the bottom to maintain equality, I must do on the top. So I end up with the square root of 150 divided by 15. If you remember, this equals the square root of 225, which is a perfect square. The square root of 225 is 15. So now I can just write the 15 right here. And so now I need to break up 150. So I hope you recognize that 150 is divisible by 25. That's the only square number that divides into it. So this top part becomes the square root of 25 times the square root of 6, because 25 times 6 is equal to 150 over 15. The square root of 25 breaks down into 5 times the square root of 6 over 15. And I can reduce that one more time. 5 and 15 reduce down by 5 to leave me with a square root of 6 over 3, because 5 goes into 15 3 times. That's my final answer. So it's getting a little crowded over here. I'm going to change colors and maybe kind of block some of this off a little bit. Sorry about that. So this gets multiplied just like we did in number 2. So the square root of 5 times the square root of 6 equals the square root of 30. And if you look at 30, 30 has no square factors. So there are no numbers on this list. 1, 4, 9, 16, or 25 would be our only options, and none of them divide evenly into 30. Therefore, I cannot simplify it any longer. Now, this problem says solve for x. This is a missing side. Now, finding missing sides, there are 2 ways. It depends on what I've been given. If I can either use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, or I can use a trig function. In this case, Pythagorean theorem would be the best option because I have 2 sides, all right? So this is the hypotenuse, this is the leg, all right? And so I'm going to use leg squared plus leg squared equals hypotenuse squared. I like to do it like this because a squared plus b squared, people always ask me, well, which one's a, which one is b? It doesn't matter. They're both legs. See, it's always the hypotenuse. So how about that? So we're going to do 4.1 squared plus, and you can call this b if you want, or x, equals 11.4 squared. So you do your math. So 4.1 squared, 16.81. 11.4 squared is 129.96. I'm trying to isolate b squared, so I'm going to subtract 16.81 from both sides. Typing it into my calculator, I get 113.15. And then I want to take the square root of both sides because I'm trying to get the b by itself. I need to get rid of the square. And the final answer, I'm going to round to one decimal place, is 10.6. For number 6, I get to once again use leg squared plus leg squared equals hypotenuse squared. This is a leg, this is a leg. I'm looking for the hypotenuse. So I have 8.6 squared plus 11.2 squared equals hypotenuse squared, or we could say c squared. And students, it's crucial that you put the numbers in the right spot or you will get the wrong answer, unfortunately. So I'm going to square those two numbers and add them together. And so I end up getting 85 point, so that's not right, 8.6 squared plus 11.2 squared gives me 199.4 equals c squared, and then I'm going to take the square root of both sides. So the reason I knew my answer wasn't right was because of the way I typed it in. I got 80 something, and I knew that this was going to be more than 80 something. So I used my reasoning skills, and I'm going to take the square root of 199.4, and I get 14.1 as my final answer. Okay? So now, let's look at number 7. It says find the measure of angle A. So I'm looking at a triangle, and here's angle A. And I realize that, okay, these are supposed to be angle measures here. So here's an angle right here. Here's an angle right here. And this is my 90-degree angle. So since this angle here is 90 degrees, that leaves 90 degrees left over for these other two angles. So that means that x plus 44 plus 64 plus x must equal 90. Now, yeah, I could actually add all three of these together and set them equal to 180, but remember, we want to work smarter, not harder. So I'm combining my like terms, so 1x plus 1x is 2x. 44 plus 64 is 108. I'm using the calculator to help me out so I don't make any careless mistakes. Alright, so I'm kind of running out of space, but I'm going to subtract 108 from both sides. Okay, and I'm going to continue over here. So I'm going to get 2x equals, and then 9 take away 108 is going to be 99. And it's actually negative 99. Divide both sides by 2. And we get x is equal to negative 49.5. And I know it's kind of weird to have a negative number. Let's go back and check that. So I found a little mistake. I wrote 9 here when it should have been 90. So it's going to change this word. My apologies. Sometimes that happens. We make a transcription error. But I knew something was weird because of the answer I got. So anyway, 90 take away 108. It's going to give us negative 18. So I get 2x equals negative 18. Divide both sides by 2. So now x equals negative 9. And when I test that in these angles right here, okay, when I plug in negative 9 in plus 44, I end up with a positive number. And 64 plus negative 9 gives me a positive number. So now I feel better about that answer. The problem over here, number 8, works the exact same way. So we have 7x plus 2 plus 14x plus 4 equals 90. So I'm combining my like terms. So 7x plus 14x is going to give us 21x. I always like to write my x's first. And 2 plus 4 equals 6. Okay. And that is equal to 90, making sure I'm writing that correctly. So always go back and review your work, survey your work to see if you made any careless mistakes. Anybody can make a mistake. We're all human, okay? We're not robots. So this is 84, and then we're going to divide both sides by 21. So 84 divided by 21 is equal to 4. Number 9, solve for each variable in the special right triangle. Ah, your favorite thing to do, special right triangles. So here's the little method we use. We did 45, 45, 90. All right, and make that a little bit too long. So then we know that the legs are both x, 2 congruent angles, 2 congruent sides. And then this is x squared roots of 2. And so some of you might ask, well, how do you remember what this is? I just remember it's a radical, and I think, oh, 2 x's, so I have 2 there with the x. And then I put my numbers in. So this is a leg, and it's opposite a 45-degree angle. So this is radical 6 over 6. This is radical 6 over 6. And we're missing one of the sides. So if this is radical 6 over 6, this is also radical 6 over 6. But we're looking for the hypotenuse, so that's this one right here. All right? So this statement is telling me that x is radical 6 over 6. So that means that this x is radical 6 over 6. So I have to write radical 6 over 6 times radical 2. Erase my little star right here, and then multiply this out. That's radical 12 over 6, and radical 12 breaks down into radical 4 times radical 3, which is 2 radical 3 over 6, which continues to break down. 2 over 6 reduces to 1/3, so this is radical 3 over 3. All right, so that is the very first page. Here is the next page. So we are looking at number 11. It says find each side. Oh, I think I didn't finish the other problem on this first page. Let's go back. Sorry about that. So we have another 45, 45, 90. So this is 45, 45, 90. This is x radical 2. And then I know that the hypotenuse this time is 3 radical 2. Oh, I love it when it works out like this, because check this out. So these two are equivalent. That means that this radical 2 here is the same as this radical 2 here. And this x is the same as this 3. So x is 3. So boom, boom. So these two legs are both 3. How easy was that? Okay, so now let's look at number 11. So number 11, we are being asked to find all the missing values. And so we have 2 missing sides. So I have an angle measure. So when I know one length and I have an angle measure, I'm good, because I can use SOHCAHTOA. Remember, this is sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So now, if this is my angle, I need to decide, well, which side am I going to do first? So I'm going to do the hypotenuse x. So this will be my h, and this would be O. So I'm going to use the sine function. Sine of 60 degrees equals opposite over hypotenuse. So x is on the bottom, so we divide. Remember, we switch and divide. So x is going to equal 2 divided by sine of 60. Then I pick up my calculator, turn it on, and I go 2 divided by the sine of 60. Close my parentheses, and I got 4 radical 3 over 3, and I'm going to change it to a decimal, and so it's going to be 2.3. Now, to find y is going to be this part over here, so I'm going to change some things a little bit. So I'm still going to use this one, so this is still opposite, but now this is adjacent. That's a trig function. So I'm going to go the tangent of 60 equals the opposite side, 2 over y, which is the adjacent side. Y is on the bottom, same as x on the bottom, and unknown is an unknown. So that means I'm going to divide. So y equals 2 divided by the tangent of 60. And I just type that into my calculator. And I get 2 radical 3 over 3. I'm going to convert it to a decimal, and I get 1.2. All right, number 12. And you know what? When I look at these, honestly, I really should have done this as a special right triangle. So if this was a multiple choice question, your answer really would have been written as a radical. So that would have been 2 radical 3 over 3. So instead of redoing the problem, I'm going to do number 12 as a special right triangle, okay? Please forgive me. So anyway, we have our 30, 60, 90, right? And so we know that the side opposite the 30-degree angle is x. The side opposite the 60-degree angle is x radical 3. And the side opposite the 90-degree angle is 2x. All right? And so I look over here. So the side opposite the 30-degree angle is 2 radical 5. So that means x is 2 radical 5. So this x is the same as this x over here. So I can put 2 radical 5 in place of that x. Okay. So I can say this is x times radical 3. So x is 2 radical 5 times radical 3, which is 2 radical 15. And I can't do anything else with that, ladies and gentlemen. And this is going to be 2 times x. Well, x is 2 radical 5. So when I simplify that, I get 4 radical 5. Number 13 says each side of an equilateral triangle is 12 inches. Determine the height. Oh, I love this picture. You got to think. So here is an equilateral triangle. That's my quick version. Each side is 12. Now the height would be this. It's also known as the altitude. So the height is 12 inches, and I'm sorry, the size of 12 inches, we're looking for the height. So that's where my x goes, okay? So I know that sometimes it's a little confusing to have a picture like that, so I'm just going to pull off 1/2 of the triangle. I'm going to change to a different color. And one of the things we need to think about is, what is this angle measured right here? So if it's an equilateral triangle, that means all the sides and all the angles are the same. So if I have 3 angles in a triangle and I have 180 degrees for all 3 of the angles, if I divide by 3, that means that each angle, this angle would be 60, this angle would be 60 degrees, and this angle here would be 60 degrees. So I'm going to stick a 60 right there. And I know this is 12. And so I'm looking for the height. So I'm going to put an x here. So then what trig function? Well, here's my angle. So relative to that angle, this will be opposite. I know this is my right angle, so this will be the hypotenuse. So that would be the sine function, because I'm looking back up here, opposite over hypotenuse. So the sine of 60 equals opposite x over hypotenuse, which is 12. So x would equal 12 times the sine of 60. So do that in my handy dandy calculator. Sorry if I'm a little hoarse. So I get 6 radical 3, and it didn't tell us how to write our final answer, but I'm just going to give the decimal version, which is also for 12.4 inches. Okay. Number 14. It says find the value of each trig ratio. So when you see the word ratio, think fraction. Okay? Now, it says give the answer as a reduced fraction and as a decimal. So you're going to give your answer 2 ways. So a lot of you would give your answers as decimals, so that's good. You got a lot of practice. So cosine is adjacent over hypotenuse, so here's x. So this would be the hypotenuse here.
Good afternoon, Grayson. It's time for your afternoon
Adjacent
announcement.
side. Okay, sorry, I had to pause for a moment. And so now we're back. Something's wrong with my screen here. Okay, that's better. So we left off with this problem. So we were calculating the cosine of x, and we were writing our answer 2 ways, both as a ratio and as a decimal rounded to the nearest 10,000ths. So the nearest 10,000th decimal place is the 4th decimal place. You have tenths, hundredths, thousandths, 10,000ths. That's the 4th decimal place. So the cosine of x equals the adjacent side, the length of the adjacent side, which is 10, over the length of the hypotenuse, which is 26. And we would want to reduce that. And so 10 and 26 both reduce by 2 to give us 5 over 13. And then I'm going to take my calculator and do 5 divided by 13. And I'm going to write that as a decimal in 4 decimal places, 0.3846. Next problem, the tangent of A. So here's angle A. This is my reference angle. So relative to angle A, I'm going to need the opposite side and the adjacent side. So the tangent of angle A, let's move this out of the way, is going to equal the length of the opposite side. So this would be the opposite side, and this is the adjacent side. Now remember, the opposite side is the one that you can't touch. So if you were standing right here, you can touch the hypotenuse, you can touch the adjacent side. You cannot touch the side of length 8, which makes that the opposite. So this ratio would be 8 over 6, which reduces to 4 over 3. And the tangent of 4 over 3 written as a decimal would be 1.3333. And so tangents will often be decimals larger than 1, depending on the angle measure. Number 16, solve for x. Round to the nearest tenth, so that's 1 decimal place. Okay, and so here's x. So when you have to solve for x, you got to think, okay, what am I looking for? Am I looking for the measure of an angle, or am I looking for the measure of a side? That's important because that determines whether you're using a regular trig function or an inverse function. So since I'm looking for a side, I'm just going to use a regular trig function. I'm only going to label what I need. So this angle here is a 73-degree angle. So this would be the adjacent side. This would be the opposite side. So I'm going to use the tangent function. I always just like to write the little quick version of the formula down so that I fill my numbers in properly. I notice that sometimes students will fill the numbers in inverted or upside down, and then it changes the whole nature of the problem if you don't write it correctly. So as I look at this problem, I remember, x is on the bottom. When x is on the bottom, I have a little shortcut. We divide. We switch and divide. So the x and the tangent of 73, we change those up, and we say x equals 12 divided by the tangent of 73 degrees. And that's basically a shortcut for multiplying or cross multiplying and dividing. So 12 divided, so I'm using my calculator. 12 divided by the tangent of 73 is 0.3668, and we are rounding to one decimal place, so that would be 3.6 or 3.7 is the answer. 3.7. So make sure you're working this out. Make sure you're understanding. Make sure you're pausing this as I'm working, and you are verifying the work that I do. If you are just watching me do this, then you are not building those bridges. You know how I talked to you about building bridges, how you need to kind of burn this into your brain by repetition. You watch me do it, you say out loud in words what I did, you write down what I did, you do the math, you cover it up and try to recall it. And then if you can't recall it, you look at it again until you can recall it, and then it's yours. If you're not doing those things, you're not doing what it takes to remember how to do the math, okay? Math is work. So now I'm looking for the length of this side. Here's my reference angle. So relative to this angle, this side is the opposite side. It's the one I can't touch. The right angle points to the hypotenuse, so that is my hypotenuse. And so which trig function is that? SOHCAHTOA. That sounds like the sine function. Sine equals opposite side over the hypotenuse. So I'm going to write the sine of 40 equals the length of the opposite side over the length of the hypotenuse. X is on top, which means all I have to do to get the answer is multiply. So x will equal 16 times the sine of 40. And remember, I always write that number first and then the trig function. It keeps from creating issues with getting the correct answer. If you do it the way I show you, I promise you it'll work out correctly every time. Okay, moving right along. And my final answer was 10.284, which rounds up to 10.3. Excellent, excellent, excellent. So let's keep it moving. And so we have two more problems. I'm going to record this review in parts. And so the first sheet front and back will be part one. So we're almost at the end of part one. So it says state if each triangle is a right triangle. Well, if a triangle is a right triangle and I know the lengths of sides, I'm really testing to see if the values in the triangle meet this criteria, if they give you a true statement. Now remember, my way of writing a squared plus b squared equals c squared, leg squared plus leg squared equals hypotenuse squared. Okay, so it doesn't matter which leg you use first as long as it's a leg. So this is a leg, this is a leg, this is a hypotenuse. This is the leg, this is the leg, this is the hypotenuse, and I know that because it's across from the right angle. Remember, the right angle is like an arrow that points to the hypotenuse. You should hear my voice saying that every time you see a right angle, because I say that every day. So I want to determine if 6 squared plus 8 squared equals 13 squared. So that's the question I'm asking. So I'm going to do the math on the left. So 6 squared is 36, 8 squared is 64, and this equals 169. So I want to know, well, 36 plus 64 is 100, and 100 is not equal to 169. In fact, it's less than 169. So not only is this not a right triangle, it is an acute triangle. However, the question didn't ask for that. They just wanted to know if it was a right triangle. But I'm just going to go ahead and write down here that it's acute, just because that's a good review question. Okay, here is the last problem on this page. So I'm going to change the colors up just to help distinguish the two different problems. So I have 4 squared plus 4.2 squared, and I want to determine instead of putting an equal sign there, I'm going to put a question mark there. I want to know if that equals 5.8 squared. Now, this is not something that I just stare at and do in my head. I'm using my tools, my calculator. So I have 4 squared, which is 16, and then 4.2 squared is 17.64, which makes sense. It's going to be more than 16. And 5.8 squared is equal to 33.64. Alright, so then let's add these two together. So 16 plus 17.64. I got 33.64, which equals 33.64. So yes, it is a right triangle because the left side is equal to the right-hand side. So that concludes part 1 of the Geometry Unit 3 test review packet.